because we're running out of time. What are they doing? What is this graph doing at that point? In English, in verbal words, what is that graph doing at that point? What is the graph doing at that point? This is called the x-intercept because that's where it's crossing the x-axis. This is called the y-intercept because that's where it's crossing the y-axis. The terms that we're given these things, again, is whenever you take notes, don't just put it in your bag and forget about it. Look over them at least once or twice before the next class. The topics in your next 2 or 3 or 4 courses in math will only get more complex. You have to review your notes. This is the basics of the basics. So what does an x-intercept mean from your notes? And what does a y-intercept mean? How do we find them? What's the location of the x-intercept? Yeah, what's the location? What's that location? What's that point? Oh, we know it's the x-axis, yes. But what's that point? What's the location? -1 would be here. It's only going from further from there. It's -7, 0. What's the location of that point? So this is the x-intercept. It looks like this. So how do we get the x-intercept? What has to be true? For any point, if I had this line, there's the x-intercept. It's crossing the x-axis. What's that location? What's the location of this one? So with all 3 of these, what do you notice the same? But they're all points. All 3 of them are points. But what do you notice about all 3 of these points? What's that? The y equals 0. You can't tell the slope from these points. These are locations. These are x and y components. In each one of them, the y is equal to 0. So to find the x-intercept, you have to set y equal to 0, and then you have to solve for x. That's how you find the x-intercept. That's what we did here. We set y equal to 0 and solve for x. So how do you think we find the y-intercept? Set x equal to 0, because x has to be 0. And then solve for y. Look at this question. X plus y equals 5. It says find the intercepts for the graph of the equation. Find the intercepts. Find the x-intercept. What do you have to do? Look at your notes. You just have it written down. What does it say? How do you find the x-intercept? Look at your notes. Really? We just talked about it 5 seconds ago. Set y equal to 0. So x is 5, y is 0. There's our first intercept. How do you find the y-intercept? You're asking me. So there's the y-intercept. Okay, the next one in the homework assignment, the next set. Graph the equation 9x, negative 9x minus y equals 0. This is one of those instances where the x-intercept and y-intercept won't work. So in the first x-intercept, I set y equal to 0. And solve for x. First off, I've got to change the signs. So it's positive 9x equals 0. 0 doesn't have a sign. Divide by 9. So it goes to 0, 0. Same thing's going to happen when I do the y-intercept. Set x equal to 0. So I have negative y equals 0. Change the signs. Y equals 0. So they both go through the origin. So that doesn't work. We know we have 1 point at least. We have 0, 0. What else do you need to draw a graph? To draw a graph of a linear equation, what do you need? You need 2 points. Because a linear equation is a straight line. In order to draw a graph of a linear equation, you need to know 2 points. Or the slope and the y-intercept. Do we have either of those conditions? Nope, we don't have those. So the easiest one, we have 1 point. The y-intercept, we can use that point. We don't know the slope. Or we don't know a second point. So what do you want to do? Let's find a second point. The way you find a second point, since you've used x or y equals 0 here and x equals 0 there, you can't use 0 anymore. So we'll pick another point. Let's say x equals 1. Pick any other x, doesn't matter which one. Plug it in there. -9 times 1 minus y equals 0. Negative 9 times 1 is -9. Solve for y. Add y to both sides. So y is equal to -9. So there's your second point. So to graph it, the first point is at 0, 0. The next point is at 1, 1, 2, 3, 4, 6, -9. And there's your graph. Right? Let's look at finding slopes of lines. Chapter 13, what section was that? Section 5. Slopes of lines. We can find the slope of a line by 1, its graph, its equation. And there's another one, I don't know if we're going to cover it in this section. So we're gonna get two of them from its graph and from its equation. Well, we've done another one before. 2 points. Really, the first and third one are really the same. For example, this is an example. Find the slope of the line going through the points 3, 5, and 1, 1. Remember from last time what slopes mean? What do slopes mean? How do you define a slope? Rise over run. Slope is defined in words as the rise over run. It's the vertical change over the horizontal change. Vertical change over the horizontal change. What variable, which axis is the vertical axis? What does vertical mean? What does horizontal mean? Vertical is up and down. Right. So which axis is up and down? The y-axis, right. So in mathematics, this little symbol here, the delta, means change. So it's delta y over delta x. Also in mathematics, we don't write the word slope. The slope is represented by the letter m. How do you find the difference between two vertical points or two horizontal points? Change means the difference. So what's the difference between 2 and 9? How far are they apart? They're 7 apart. How about 3 and 48? How about 7 and 91? You see, I don't want you to count like you did here. 3, 4, 5, 6, 7, 8, 9. No, there's a formula we talk about. How do you know how many numbers between 2 and 9, 3 and 48? We have the answers. Subtract them. we take 9 minus 2, you get 7. If you take 48 minus 3, you get 45. So 91 minus 7 is 84. So if I give you any two x values, how do you find the distance between the two x values? The bigger one minus the smaller one, or the second minus the first. Or same thing with the y values. I have y1 and y2. What's the difference between the y values? y2 minus y1. So the change in y is y2 minus y1 over x2 minus x1. That's the formula for a slope, and that's how we figure it out. We always start with a definition. And what do they mean? Now the question is, what are x1, x2, y1, y2? Remember, we have 2 points to find the slope, right? So we have 0.1 and we have 0.2. Right, we're getting, yes. So 0.1, it's made up of an x and y, right? And so is 0.2. How do we tell them apart? Well, 0.1 has x1, y1. Those belong to 0.1. x2, y2 belong to 0.2. So the subscripts tell you where those numbers come from. The subscripts, x sub 1, y sub 1 belong to 0.1. X sub 2, y sub 2 belong to 0.2. Now in ours, this is 0.1 and this is 0.2. So that means this is x sub 1, that's y sub 1. This is x sub 2, and that's y sub 2. So the first thing you want to do is label these things. What's x sub 1? X sub 2, y sub 1, and y sub 2. Now that you have this and you have your slope equation, all you have to do is plug and play. y2 is 1. y1 is 5. x2 is 1. x1 is 3. They have different signs. 1 minus 5. The answer will be positive or negative? Negative. Negative what? Yeah, 5 minus 1 is 4. 1 minus 3. 3 is bigger than 1. The answer should be negative. 3 minus 1 is now we simplify. The negatives cancel each other out. 4 divided by 2 is 2. So the slope between those 2 points is 2. Actually, it's 2 over 1. I'll show you what that means. Why? You can say it's 2, but you have to know it's 2 over 1. Let's see what this means. In other words, whenever you have slopes, don't put them in decimals. Leave them as fractions. I'll show you why. So 0.1 is where? What location is 0.1? It's where? 3, 5. So it's over 3, up 5. This is at location 3, 5. That's 0.1. 0.2 is at 1, 1. This is 0.2. This is 0.1. So what the slope tells us, it tells us how to get from one point to the next. That's why I said, that's why the fraction is important. Remember, it's the vertical change over horizontal. So up 2 over 1. Up 2 over 1. So we get to it. Because to start from this first point, and it says go, since it's positive, I go up 2, and the bottom's always positive over 1. Not there yet, so it's up 2 over 1 again. So that's how you read the slope. If it's negative, I would have gone down and always to the right. Slope, the top number can either positive, it goes up, negative, it goes down, and the bottom number is always positive. So that's how you find slopes if I give you 2 points. What if I give you a graph? Find me the slope of this graph. And we'll do it 2 ways. So what do you think the first way is going to be? How do you mean? This point? 1, 2, 3. So it's closer. Okay, so where are they? So where do I put that? What do I do with that? Those 2 numbers. What does -3 and 2 represent? What does it mean? Why'd you find those? You found them for a reason. Anybody help?
Write down the numbers for each point.
So what would I write for this one? Right. What you just found me was the location, -3 and 2 at that point. They're more just numbers. That's a location. That's the reason you pick those numbers, because that's exactly where that number sits. So what's the other one? Mhm. Now what do? This is looking for a slope. Very good. Now, the first method we're going to use the equation. Since we have 2 points, we have 0.1 and we have 0.2. Since we have the locations of those 2 points, can we plug them in the equation? What's y2? -3 minus what's y1? See, this is why it's easier if you do this first. Because once you define these, finding the slope, finding the equations of lines, finding anything is much easier. You just have to reference these locations. So what is x1? X1 is -3. X2, it's the x value of the second point. Y1, it's positive, so it's this y value of the first point, and y2, -3. So now all we have to do is look at this list. Y2 was -3 minus y1 is 2. X2 is 2 minus a -3. That's it. Now, once you have these labeled and you have the equation, it's just plug and play. There's not much more to do. On the top, -3 minus 2. They're both negative, so the answer is what sign? Negative. 3 plus 2 is 5. On the bottom, you have 2 negatives next to each other. What happens there? Yeah, so it's 2 plus 3 is 5. So our slope is what? When you simplify this, what is 5 divided by 5? How many times does 5 go into 5? Once. 5 goes into 5 once. So it's -1/1, which is -1. When two numbers cancel, it doesn't become 0, it becomes 1. Because cancellation is how many times does one number go inside the other. So -1/1, which is what that really means. What does that mean? Well, so which direction? I start from the first point. Which direction do I go? Down because it's negative. Down 1/1. Down 1/1. Down 1/1. Down 1/1. Down 1/1. So we got to it. Or we also could have used this one to get the graphically. Down 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it's down 5/5. Yeah. Well, this is what your answer you do, because you have to simplify the equations. But graphically, it means this. This one goes from this point to this point. That's what those numbers mean. This one tells you the slope, because the slope is really down 1/1. Because the slope is not really these 2 points, it's between any 2 points on the graph. So what you would enter in the computer would be that as your answer. So you could do it algebraically That's one way of finding the slope of a graph. The second way is count from one point to the other. The way you do this one, make a box, draw a horizontal line through that one and a vertical line. Draw a vertical line and a horizontal line to that second dot. Because I want to go from this dot to this dot. So do I go up or down? I go down, so the slope is negative. So from this line to this line, how far is it? 1, 2, 3, 4, 5. So it's down 5. And then from this point to this point, 1, 2, 3, 4, 5. Which is -1. So when you make the boxes around these 2 points, that tells you how far you go from here to here and how far you go from here to here. You just count them. This is down, so it's 5 down and 5 across. So that's really the first way. If I give you a graph or 2 points, this is how you do it. Now the second way. From an equation. The equation we're going to look at looks like this. Y equals mx plus b. M represents what? Slope. And B represents the y-intercept. So if I give you an equation, 4x plus 2y equals 6. Find me the slope of that equation and graph it. Well, is it in this form? No, we have to solve for y. So the first thing to do is solve for y. What do you have to do first? Which one? No. We're trying to get the equation here. We want to solve for y. How do you solve for y? You want to get y by itself. What's the first thing you have to get rid of? The 4x. This is one number. How do you get rid of the 4x? Why would you divide it? What's it multiplied to? You're solving for x. Is 4x multiplied to y? No, so you don't divide. How is 4x connected to this y number? It's addition subtraction. So how do you get rid of positive 4x? What's the opposite? Negative 4x to both sides. 4x minus 4x cancels out. We have negative 4x plus 6 on that side. Now you want to get y by itself. So you have to get rid of the 2. How? How is 2 connected to the y? It's multiplied, yeah. Because there's no sign between there, so it has to be multiplication. So what's the opposite of multiplication? So we divide both sides by 2. Each number separately. Each term. So here we have the 1 negative, so the answer is negative. 4 divided by 2 is 2. X. 6 divided by 2 is 3. So what's the slope of this equation? -2 or -2 over 1. What's the y-intercept? The b value. 3. Or it's actually 0, 3. Because it's going to ask you a couple ways. What is the location of the y-intercept, or what is the y-intercept? If it asks you what is the y-intercept, it's 3. If the location, it's 0, 3. Let me draw my graph here. To draw your graph from an equation, from this equation, always plot the y-intercept first. Plot the y-intercept first. Here are the steps. 1. Solve for y. You're now in y equals mx plus b. Second step. Plot b. Because once you have the y equals mx b, this is just the number on the y-axis. It's at +3. From b, follow the slope, m. So here's my y-intercept. My slope is -2 over 1. So from here, I do what? From the b value, follow the slope. So what do I do? What's the slope tell me to do from this point? How many spaces? Go down 2, very good. 1, 2, and then over what? 1, because it's over 1. There's your second dot. Connect the dots, and you're done. All right, let's do another one. I'll give you another equation, and you tell me what the graph is. Show me the graph. All right, let's look at this. What's the first thing you gotta do? Very good. Because the first thing you have to do is solve for y. So you have to get rid of the 3x. Excellent. Good point. 3x minus 3x cancel. So minus 3x plus 2. You can't combine them because that doesn't have an x. Not the right terms. Okay, is y by itself? No, it's got a negative in front of it. Change the signs across the board. So negative 3x becomes positive 3x, positive 2 becomes negative 2. So this is your equation you're going to deal with. Thing here. Because on your computer, the way you do this, it asks you to graph this. What's the first thing where's the first dot you'd put? Always put it on the constant. What does that number represent? The y-intercept. So it's negative 2. Just go and click there and it puts a dot. Where's my next dot? Well, I follow the slope. 3/1. Has to be a fraction. So the slope from this point, I do what? Go up 3. 1, 2, 3, and over. Those are my dots, and there's my line. It's a positive slope. How do we know it's a positive slope? Well, as x gets bigger, it gets higher. So that's a positive slope. So as x goes to infinity, y goes up. So as x goes this way to infinity, y goes up. That's a positive. So negative slope would be going down. Negative slopes go down. So as x goes to infinity, y goes down. We also know this is a positive graph because the slope is positive. All right, in the next couple of sections, actually, the whole entire next chapter and the next section will deal with these next type of problems. The next topic we're going to talk about are parallel, perpendicular, or neither. The symbols we use. When you see lines like that, that means they're parallel. Perpendicular is an upside down T. So these are the signs that go along with these words. So that you have to write these big words. You just put the symbols and that's what it means. Because here, what we're looking at here, now we're looking at two lines. We're going to compare two lines. Four things can happen when you have two lines. This is line 1. This is line 2. This is line 1. It's also line 2. This is line 1. This is line 2. Line 1, line 2. These are the graphic representations. I write these down because I'm going to put the definitions on these and then I'll move to the next page. You'll need a lot of space. If you need more paper, I got paper. So in this first one, what do you notice about the lines? What are they called? They look like this, right? So they're parallel. Parallel lines never touch. So they have no solutions. As you can guess, when we're talking about solutions, we're talking about how many times the lines cross. This little box here, anybody know what that box means there? 90 degrees means the right angle. Very good. If you have two lines that create a right angle, 90 degrees angle, those are perpendicular lines. They have one solution. The solution is where they cross. This one down here, line 1 and 2, they're the same line. Because they're the same line, they have infinite solutions. Every point is a solution because they both share it. And the last one is any other line. It has only one solution. Where they intersect. Are these 4 pictures okay? Everybody understand these 4 pictures? Yeah, parallel lines that never touch, so you have no solutions. Perpendicular lines are 90-degree angles, the right angles to each other, so they only have one solution. Same lines always touch, so they have infinite solutions. And any other line only touches one time, they have one solution. If we have 2 lines, how do we tell which one of these 4 they fit into? Remember, when we talk about lines, we're talking about lines that look like this: y equals mx plus b. So if I give you an equation with two lines, the first thing you have to do is make sure they're put into y equals mx plus b. Because what are you going to compare between these two lines? How would you know that these two lines are parallel? If I showed you two equations, how would you know if they're parallel? Also, look at this equation. There's only two variables in there. What are they? Yeah, the m and the b. Only ones that matter to us. X and y are whatever we throw in there. So what do you notice about the parallel lines? You have the same what? No, the same lines are down here. These can't be the same lines because they're not touching each other. They have no solutions. We're only looking at M and B. If two lines are parallel, what are they? How are they the same? Well, they have to have the same slope. The same slope has to be up one over, or whatever the slopes are, has to be the same. So the slope of line one has to equal the slope of line two. If the slopes are the same, how do we know that they're different lines? They have to cross at different y-intercepts. They have to cross the y-axis at two different points. They have the same slopes, but two different y-intercepts. Well, then look at the same line. What do line 1 and 2 have in common? If they're the same line, what do they have in common? Okay, the slopes will have to be the same. And what else? If they're the same line, they better have the same. They better have everything the same if they're the same line. So they have to have the same y-intercept. That's the only way you can tell these two types of equations apart. They both have the same slopes. But if the y-intercepts are different, they're parallel. If they're the same, they're the same line. So that's how you tell these two, the parallel lines and the same lines. Same slopes, different y-intercepts. How about these guys over here? Do they have the same slopes? No, by no means. And we don't really know what their y-intercepts are because these can be the y-intercepts. They can cross at 0, 0 or on the y-axis. So the only thing we can tell if it's these two is the slopes. Obviously, slope 1 and slope 2 are not the same. Same thing down here. Slope 1 and slope 2 are not the same. So what differentiates them? How do you know which one's which? If the slopes are the same, has to be one of these. If the slopes are different, has to be one of these. What tells these two apart? The only thing that tells them apart, they both have different slopes. This slope has a unique difference. The slope of the first line is the negative reciprocal of the second one. The slope of the first line is the negative reciprocal of the second. Put your phone away. Off away, off in your bag, not anywhere on your desk. Because nobody's answering questions. If they do, get them wrong. I don't want to see any more phones ever, rest of the semester, anybody who's in this room. So let's see what this stuff means. Here's the slope. Here's the slope parallel and the slope perpendicular. Okay, let's finish this real quick. So if the slope is 3, what's the slope of the line parallel to it? Parallel means it's the same slope. You have it in the picture, and we just talked about it 5 seconds ago. So if it's perpendicular, this slope is 3/1, and it's positive. So to find the perpendicular slope, I got to flip it and change the sign. Flip and sign change. So at -4/5, parallel are the same ones. Perpendicular, you got to flip them. Used to be negative, now it's positive. If it's 0, I'm winding up. The opposite of 0 is undefined. Because 0 would be 0/1. This one would be 1/0, and it's undefined. So the perpendicular to an undefined slope is the 0 slope. All right, so that does it for today. Review your notes because I'm going to start picking up the pace because we only got a week and a half left.